Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 81 to the power of x equals 27 to the power, we have 81 to the power of x minus 27 to the power of x equals 0. Now what I'm first going to do is I'm going to change 81 to 3 to the power of 4. So I'm going to replace 81 with 3 to the power of 4. So now we have 3 to the power of 4 to the power of x minus, now I'm going to change 27 to 3 to the power of 3. So now we have 3 to the power of 3 to the power of x. And this is equal to 0. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. Meaning 3 to the power of 4 to the power of x, well, this would equal 3 to the power of 4 times x, or we could also write that as 4x. Minus, now we're going to do the same thing over here. 3 to the power of 3 to the power of x. This is the same thing as 3 to the power of 3 times x, which is simply just 3x. Now this is equal to 0. Now I'm actually going to add 3 to the power of 3x on both sides. So now we get 3 to the power of 4x. These two cancel out. Equals 3 to the power of 3x. Now, because these two bases are the same, this also means that the exponents here are the same as well. Because if we have a to the power of b equals a to the power of c, this means that b is equal to c. Meaning 4x is equal to 3x. So now if I divide by 3 on both sides, I get 4 over 3x is equal to x. Meaning the only value that would fit this would be 0. So x is equal to 0. And as you can see, if we plug 0 in for this equation, we get 81 to the power of 0 minus 27 to the power of 0 equals 0. And anything to the power of 0 is 1. So we get 1 minus 1, which does equal 0. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x plus 2 plus 4 to the power of x plus x plus 5 equals 65. So what I'm first going to do is I'm going to rewrite 4 to the power of x plus 5 as 4 to the power of x plus 2 plus 3. And we are still adding this with 4 to the power of x plus 2. And this is equal to 65. Now, if we have something in the form a to the power of m plus n, this is also equal to a to the power of m times a to the power of n. So as you can see right here, we have 4 to the power of x plus 2 plus 3. This is also equal to 4 to the power of x plus 2 times 4 to the power of 3. And this is equal to 65. So now I'm going to actually factor out 4 to the power of x plus 2 from the left side of this equation. So if I do that, we get 4 to the power of x plus 2 times 4 to the power of x plus 2 divided by 4 to the power of x plus 2 is 1, plus 4 to the power of x plus 2 times 4 to the power of 3 divided by 4 to the power of x plus 2 is simply just 4 to the power of 3, and 4 to the power of 3 is 64. Now, 1 plus 64 is 65, right? So now if we divide by 65 on both sides, these two cancel out, and we would simply get 4 to the power of x plus 2 is equal to 65 divided by 65 is 1. Now, if you guys know, 4 to the power of 0 equals 1, because anything to the power of 0 equals 1. So I'm actually going to replace the 1 with 4 to the power of 0. Now, because both of these bases here are the same, because both of the bases are 4s, we know that the exponents are the same as well, meaning x plus 2 is equal to 0. Now, as you can see, we have a simple equation, and if we subtract 2 on both sides, we get x is equal to -2. So this is our answer.